Hi everyone and welcome to the Learning Curve. In this lesson, I will be continuing my series where I'm reviewing past paper questions on all topics which have featured on the Caribbean Examination Council's CSEC past paper examinations over several years. This lesson is focused on matrices, where we are given this system of equations 3x plus 2y equals 5 and 2x plus y equals 3, and in part 1 we're asked to express this system in the form ax equals b. So we're asked to express this system in the form ax equals b. So to do this, what we're going to do is that we're going to write down a set of matrices. We're going to write down A, which is going to be our coefficient matrix. That is the numbers that are multiplied by the unknowns in this matrix, which are 3, 2, 2, and there's an invisible coefficient of 1 for y. So this is the coefficient matrix A. We're going to also write the matrix X, which is a vector of the unknowns. And the unknowns here are x and y. So x represents a vector of the unknowns, x and y. And then b, or sometimes this is referred to as b underbar, if an underbar is given. B will represent the constant values, the constant equivalent values, which are on the right side of the equation here. So b, which is the constant of equivalent values, will be 5, 3. So now that we have defined A, X, and B, we're going to say, therefore, when we write this matrix in the form AX equals B, it's going to be simply like this. It's going to be 3, 2, which represents A, 3, 2, and 2, 1, that represents A. X is our vector or column vector of unknowns, which is XY. And this is equal to B, which is the constant equivalent values, which is 5, 3. So that completes part 1, where we have written the system of equations in the form AX equals B. Now for part 2, we're asked to hence find X and Y, which are the unknowns in this system of equations. We could have used other methods like simultaneous equations to solve this, but in this particular question, past paper question, we are using matrices. So to find x and y here, I will say xy is going to be equal to A inverse B. That's what xy is going to be equal to, A inverse B. So this is how we will find the unknowns when we are given a system of simultaneous equations and we are solving it using matrices, having written the equation in the form ax equal b, matrix form. Then to solve for x and y, we will find A inverse and multiply it by b. So that's how we will find x and y. So we already know b is 5, 3. So let us try to come up with A inverse. A inverse is found, so this is A inverse. A inverse is equal to 1 divided by, so this is always the formula for A inverse. It's 1 divided by the determinant of A multiplied by the adjoint of A. Right, so 1 upon the determinant multiplied by the adjoint. That's how we're going to find A inverse, and that's how we find the inverse of any matrix, at least one of the techniques that are available. So we're going to multiply 1 over the determinant of A by the adjoint and multiply that by the adjoint of A. So what's the determinant of A and what's the adjoint of A? Let's work those out. So the determinant of A, which is written with these two strokes around it, or we could say DETA, the determinant of A here would be found by multiplying, remember A is this, 3, 2, 2, 1. We can find the determinant of A by multiplying the leading diagonal. The leading diagonal is 3 and 1, so we're going to multiply 3 by 1. So 3 multiplied by 1. Take away the product of the remaining diagonal called the off diagonal elements, which is 2 multiplied by 2. And this is how we find the determinant of A. Again, 3 multiplied by 1, so we're multiplying the leading diagonal. And then we subtract the product of the off diagonal elements, 2 multiplied by 2. So 3 multiplied by 1 here gives us 3, and 2 multiplied by 2 gives us 4. So it means that the determinant of A is equal to -1. So we have found the determinant of A, and next we're going to find the adjoint of A. Once we have found the determinant and the adjoint, then we can find the inverse of A. So this is normally a question that attracts a lot of marks in a typical CSEC examination. So the adjoint of A, so we already found determinant A, now we're finding adjoint A. The adjoint of A is found by swapping the values in the leading diagonal. The leading diagonal here is 3, 1. Remember, diagonal is a slant line. The leading diagonal is 3, 1. So we're going to swap those around. So 1 will go here and 3 goes here. And then we're going to make the products, we're going to make the terms in the off diagonal negative. We're going to apply a -1, multiply the off diagonal elements by -1, which means that if they were already negative, they would become positive. But in this case, the off diagonal elements are 2 and 2, which are positive, so we're going to multiply -1 by them. So we're going to get -2, -2. So this is the adjoint of A. Again, the adjoint of A is found by swapping around the elements on the leading diagonal. So 3 goes where 1 is and 1 goes where 3 is. And we make the terms in the off diagonal, multiply them by -1. So they become -2, -2 here. So continuing the problem up here, I am now able to find A inverse. So I say therefore A inverse, remember that A inverse is equal to 1 divided by the determinant of A. So A inverse is going to be 1 here, applying this formula. It's going to be 1 divided by the determinant of A, which we found to be -1. And we're going to multiply that by the adjoint of A. And the adjoint of A was found to be 1, -2, -2, 3. So let's complete this now. So A inverse is going to be equal to, now let us recognize here, let us recognize that 1 divided by -1 is just going to be -1. So in effect then, to get the adjoint, I'm going to multiply -1 by all the elements inside the adjoint of A, which is this. Because again, 1 divided by -1 here will give us -1. So now we're going to multiply -1 by the elements inside of the adjoint matrix here. -1 multiplied by 1 is going to be -1. -1 multiplied by -2 is going to give us +2, because a negative multiplied by a negative is positive. Then -1 multiplied by -2 here is going to be +2 as well. And -1 multiplied by +3 is going to be -3. So this is now A inverse. Alright, so the -1 that we multiplied by here is sometimes called the scalar. We multiplied by -1 and we got this result. Now that we have found A inverse, we can now find xy. Let's go back to this statement here, that xy is equal to A inverse multiplied by B. A inverse multiplied by B is going to give us xy. So let's now write this out. A inverse was found to be -1, 2, 2, -3. That's A inverse. And B, we already know that B from part 1 of this question is 5, 3. There, B is 5, 3. So I will write here 5, 3. So we're going to multiply these two matrices, and whatever results we get will represent the values of x and y, which is what we're trying to find. So this would be equal to, let us first recognize that we are able to multiply these two matrices by each other. This is a 2 by 2 matrix, so I'm just writing the order of the matrix or the size of the matrix below it, below each of them. This is a 2 by 2 matrix because there are 1, 2 rows and 1, 2 columns. In this column vector, however, what we have is 1, 2 rows and 1 column. So this is a 2 multiplied by 1, a 2 by 1 size matrix because there's 1, 2 rows and 1 column. Once the number of, so it's always row by column. When you're writing the size of a matrix, it's always row by column. Once the number of columns in the first matrix is equal to the number of rows in the second matrix, which they are in this case, then we are able to multiply the two matrices. Again, once the number of columns in the first matrix is equal to the number of rows in the second matrix, then we are able to carry out the multiplication. This is a general rule for multiplication of matrices, which means that the order in which matrices are multiplied actually matters. So here we're going to carry out this multiplication by multiplying row by column. We always multiply row by column when we are carrying out matrix multiplication. So I'm going to do first row here in the first matrix by the column here. So it's going to be negative 1 multiplied by 5, which is going to give us negative 5. Yes, negative 1 multiplied by 5, which is going to give us negative 5. And then 2 multiplied by 3, which is going to give us positive 6. And that's how we'll get that value there. So again, row by column, row by column. So we're multiplying the first row in matrix A inverse by the given column vector B. So we multiply negative 1 by 5, which gives us negative 5, and 2 by 3 rather, gives us positive 6. So we get negative 5 plus 6. Then we're going to multiply the second row here. Use a different color. We're going to multiply the second row here in A inverse by the column matrix 5, 3, column vector 5, 3. So we're going to say 2 multiplied by 5 gives us 10. And then negative 3 multiplied by 3 gives us negative 9. So when we simplify this, we get this answer. Negative 5 plus 6, which is the same as 6 minus 5 will give us 1. And 10 minus 9 will also give us 1. So therefore, we have come to a conclusion here that xy, which is what we're solving for here, xy is equal to 1, 1. Since xy is equal to 1, 1, it means that x is equal to 1 by matching the corresponding elements here. X is equal to 1 and y is also equal to 1. Of course, x and y can be different values. Many times they are. So just to make it clear that you're not always going to get x and y to be the same values. But in this case, x is 1 and y is 1. And this is a past paper question on CSEC, on matrices. And these are common ways in which these types of matrix problems would come. Thank you very much for watching. Remember to like, share, subscribe, and stay tuned for much more on the learning curve.